machines. When you heard the word machine, do you think of large applicants, power tools, factory machines, construction equipment? All of these examples are machines. You might be surprised to learn that the devices as simple as hammers, screws are also machines. Why are these simple tools considered machines? How machines help us do work? Machines, any device, makes the work easier by changing force. When you use a machine, you apply a force to the machine. This force is called input force, and the machine in turn applies the force to an object. Force is called the output force, called that work equals force multiplied by the distance. Work equals force multiplied distance. The force applied to a machine is applied over a given distance, called the input distance. Force is applied by the machine to the object is also applied over a distance, called the output distance. Output distance may or may not be the same as the input distance. Machine may work easier by increasing the amount of force that is applied, increasing the distance of a force is applied, changing the direction in which force is applied. Contrary to popular beliefs, machines do not increase the amount of the work that is done, it just changes how the work is done. So if a machine increases the force applied, must apply the force over a short distance. Similarly, if a machine increases distance over the force applied, must apply less force. How to increase force? Example of machine that increase force are doorknobs and nut correctors. When you turn the large wheel-like handle of the doorknob, cause the cylinder central shaft of the doorknob to turn. The shaft turns a short distance with more force. When it turns, it causes a small bar to move out or into a slot in the door frame, such as allowing the door to open or close. Press together the two handles of the nut cracker, cause the other end of the handle to squeeze the nut. Squeeze the end move a short distance, but with greater force, the result in the nut cracker. This results in the nutshell cracking, so you can get a tasty nut meal inside. In each case, force applied by the user is less than the force applied by the machine, but the machine applies the force over a shorter distance. How to increase distance? Example, machine that increases distance over which force is applied, pedal and hammers. When both oppose the handle end of the pedal a shorter distance with a strong force, the other end of the pedal move a greater distance through the water with less force. To cover the great distance, pedal ends move faster than the handle ends. Water push back against the fast-moving pedals, causing the canal to shoot forward. One carpenter moves the handle of the hammer back and forth, short distance with strong force. Head of hammer moves greater distance back and forth against the nail, though with less force. By repeatedly hitting the nail, hammer drives the nail into the board. In each case, the machine increases the distance over which the force is applied, but reduces the strength of the applied force. How to change the direction of force? Some machines change the direction of the force applied by the user. They may or may not also change the strength of the force or the distances. They may or may not also change the strength of the force or the distance over which is applied. For example, a machine that works in this way, claw hammers and the rope system, pulleys that raises or lower flag on flag poles. When the user of the hammer pushes down the handle, claw of the hammer pulls up the nail. Hammer changes the direction force, also apply greater force over the smaller distance. Rope system on flagpole wraps around the wheel called the pulley. Pull down one end of the rope. The other end of the rope pulls the flag upward. In each case, the direction of the force applied by the user reversed by the machine. How does this make it easier to do the job? How to calculate the efficiency of a machine? You read above that machine do not increase the work done on an object. In other words, you can get more work out of a machine than put into it. In fact, a machine always do less work on the object than user does on the machine, because all the machine must use some work put into them to overcome friction. How much work depends on the efficiency of the machine. Efficiency is a percent of input work that becomes output work. It is a measure of how well a machine reduces friction. Refers the machine because it makes work easier by changing force. How does it change force? It's easier to push up a heavy piece of furniture from the ramp to the truck then to lift it straight off the ground. However, pushing the furniture over the surface of the ramp creates a lot of friction. Some of the force applied to the moving furniture must be used to overcome friction. It will be more efficient to use a dolly wheel. It will be more efficient to use a dolly on wheel to roll up the furniture on the ramp because rolling friction is much less than sliding friction. As a result, the efficiency of the ramp will be greater than a dolly. Efficiency can be calculated with the equation efficiency equals output work divided by input work times 100%. Consider a machine that puts out 6,000 joules of work. To produce much work from the machine requires the user to put in 8,000 joules of work. To find the efficiency of the machine, substitute these values into the equation for efficiency. Efficiency equals 6,000 J divided by 8,000 J times 100% equals 75%. With mechanical advantage of machines, and the measure of the efficiency of a machine's mechanical advantage. Mechanical advantage meant the number of times a machine multiplies the input force can be calculated with the equation mechanical advantage equals the output divided by the input force. This equation computes the actual mechanical advantage of a machine and takes into account reduction of output force that due to friction. Shows how much a machine actually multiplies force is used in the real world. What is the ideal mechanical advantage? Can be difficult to measure the input and output force needed to calculate the actual mechanical advantage. It is usually much easier to measure the input and output distances. These measurements can be used to calculate the ideal mechanical advantage. Ideal mechanical advantage represents a multiplication of input force that be achieved in absence of friction, for it is greater than the actual mechanical advantage because our machine is of some work overcoming friction. Ideal mechanical advantage calculated with the equation input distance divided by the output distance. Compare this equation with the equation above for actual mechanical advantage. Notice how the input and output values are switched. This makes sense when you recall that when machine increases force, it decreases distance, vice versa. Consider a simple ramp. Ramp can be used to raise an object off the ground. Input distance is the length of the slope surface of the ramp. The output distance is the height of the ramp. With the vertical distance, the object is raised. Therefore, the ideal mechanical advantage of the ramp is ideal mechanical advantage equals 6 meters divided by 2 meters equals 3. Ideal mechanical advantage, so it means that the ramp ideally in the absence of friction multiply the output force by a factor of 3. Input force applied along the length of the slope ramp surface. Output force applied along the height of the ramp. Input distance is greater than the output distance. This means that the input force is less than the output force. What's the relation between mechanical advantage type of machine? As above, some machine increases the force put into the machine, while other machine increases the distance of which force is applied. The other machine changes only the direction of the force. Which way a machine works affects its mechanical advantage. For machines that increases force, including ramps, doorknobs, and crackers, the output force is greater than the input force. For mechanical advantage greater than 1. For a machine that increases the distance of which force is applied, such as pedals and hammers, the output force is less than the input force. For the mechanical advantage is less than 1. For a machine that changes only the direction of the force, such as a rope system of flagpoles, the output force is the same as the input force. For the mechanical advantage is equal to 0. Is equal to 1. I'll make a summary. Machine is any device makes work easier by changing a force. Machine may increase force, increase the distance over which force is applied, change the direction of the force. Efficiency for machine is that measure how well it reduces friction. It is calculated as a percent input work that become output work. Mechanical advantage of machine is the number of times it multiplies the input force. And the mechanical advantage is the multiplication of force will be achieved in the absence of friction. It is calculated as the input distance divided by the output distance. That's it. Thank you very much. on time D minor scale, cadenza number 1, and fiddler on the roof.